Hello everyone, I'm Maurice from QuDoor, and it's my great honor to be here for the next wave 4. Considering various factors, I cannot share my speech face to face, but we can also communicate well through radio. As Director of Research and Development of QuDoor, I would like to share QuDoor's experience in quantum communication, quantum computing, and quantum intellect. The topic of this speech is QuDoor developing quantum intellect in China. My speech is mainly divided into 3 parts. The first part is global situation of quantum computing. The second part is QuDoor's quantum computing and quantum communication. And the third part is QuDoor's development of quantum intellect in China, as well as QuDoor's some exploration and expectation for quantum intellect. Okay, let me explain the first part, global situation of quantum computing. As we all know, the first quantum revolution directly gave birth to modern information technology. Based on the principle of quantum mechanics, nuclear energy, semiconductor transistor, laser, nuclear magnetic resonance, high-temperature superconducting materials, and many other applications came into being. Great change of life into a great deal in the world quantum entanglement process of a large number of experiment studies. The interactions development of the fine quantum control technology and combining with quantum control and information technology came ushered in quantum information technology represented by the second revolution. From the observation and application of quantum laws of path into active control and manipulation of quantum state, quantum communication and quantum computing in quantum information technology can meet extremely high demand for security and a huge demand for computing power in development of information technology. With more and more data to be calculated and stored, computers today face significant challenges and even limitations in some ways. For example, the semiconductor process technology is gradually approaching 1 to 2 nanometer. The movement of electrons no longer obeys laws of classical physics. Moore's law is facing the limitation, and the scale of the classical computing speed will no longer be improved. Supercomputing centers and data centers are highly energy consumption, which are unsustainable. Every consumption will be a difficult challenge. Moore's law, as mentioned, when the process is constant, the number of semiconductor transistors that can be accommodated on an integrated circuit doubles every 18 months, and so does its performance. However, quantum computing, throwing a system exascale variables using the Moore's law, as mentioned, when the process is constant, the number of semiconductor transistors can be accommodated on an integrated circuit double every 18 months, and so does its performance. However, quantum computing, throwing a system of big variables using big 10 Hz, it takes 100 years, whereas quantum computers, it takes only 1% nanosecond, 1% seconds 带出来。 Moore's law, as mentioned, when the process is constant, the number of semiconductor transistors that can be accommodated on integrated circuit doubles every 8 months, and so does its performance. Tianhe 2, currently the fourth most powerful computer in the world. It can solve the same problem in a second that Tianhe 2 took a year to solve with a quantum computer containing 100 effective qubits. From classical computing to quantum computing, information processing power will undergo a similar leap from the AbaQ to computer. In 2018, Qi Yao attended the International Quantum Cryptography Conference and said, "Through the progress of quantum computing, making combine quantum and artificial intelligence, that's to say, use quantum algorithms to understand or create new intelligence and obtain forces beyond nature. Many international research institutions are also aware of this and have joined in the research of quantum computing technology." I've made a simple comparison of several common realization paths of quantum computing technology at present. We know that ion trap and superconductivity are the two most mainstream technologies. I have not set specific parameters, but I believe that you are already very familiar with it. It's worth noting that QuDoor is focused on ion trap technology and believes it would be a breakthrough in the near year. Let me go into a little more details about two main technology paths I just mentioned. As the only physics system that simultaneously satisfies the 5 basic criteria of quantum computing and the 2 criteria of quantum network. Ion trap has characteristics of trapping literally identical quantum bits of ions, and the trapped ions can emit entangled photons, which has the advantage of lateral quantum interconnection and can realize distributed quantum computing. On the other hand, superconductivity technology, based on today's mature semiconductor preparation process, has the first, moreover, advantage. This is the map of global quantum computing technology companies according to China's Academy of Information and Communication Technology. It can be seen that quantum computing is booming. The Chinese companies involved include not only some internet or information technology giants, but also startups. At the same time, the global ecosystem of quantum computing has been relatively complete, including consulting service providers, application providers, intermediary providers, hardware providers, hardware technology suppliers, etc. Now, let me introduce QuDoor. QuDoor is the first company in China that develops simultaneous quantum communication and quantum computing. Open the door of quantum is our concept that will infect more and more scientific workers and create future together with us. Now let me introduce QuDoor. As we know, trapped iron is based on for Nobel Prize. As we know, trapped iron is based on for Nobel Prize and have physical basis. Here are the Nobel Prize in atomic physics. They are the invention of separate oscillatory fields method in 1918, Liz Cooley in 1997, cooling atoms to lowest possible energy state in 2001, and measuring and manipulation of inverted quantum system in 2012. Similar with class computers, quantum computing or quantum computing power of quantum computer is a given score. Quantum volume is a numerical value obtained by IBM according to number of quantum bits, collectivity, error rate, and other related parameters through certain mathematical operations, which roughly represents the performance of quantum computing. What can be seen from the lower left gift, the more collections and less error rate are the key to improving quantum volume. Well-known companies such as Honeywell and AbaQ currently have quantum values of 40, 64, and 4 million, respectively. Founded in January 2019, Founded in January 2019, QuDoor is a new generation of information technology innovation enterprise initiated by international senior experts and scientists returning to China. It challenged first state-level high-technology enterprise with independent core technologies and product development capabilities in quantum computing and quantum communication. The company focused on research, development, and operation of products, standards, and services based on quantum information processing technologies, and is committed to solving the core problems in information security, transmission, and mass data processing. The core team has 20 years of technology accumulation and product experience in the field of quantum information, and forward-looking to product planning and technology research and development capabilities in this field. Founded in January 2019, QuDoor is a new generation of information technology innovation enterprise initiated by the international senior experts and scientists returning to China. It challenged first state-of-the-art high-technology enterprise with independent core technologies and product development capabilities in quantum computing and quantum communication. The company focused on the research, development, and operation of products, standards, and services based on quantum information processing technology, and is committed to solving the core problems in information security and transmission and mass data processing. The core team has 20 years of technical accumulation and product experience in the field of quantum information and forward-looking product planning and technology research and development capabilities in this field. In quantum communication, QuDoor is different from other companies in technical solutions. Based on time-phase coding technology, we can achieve the mean frequency of QKD up to 125 MHz and have the ability of class communication plus quantum communication double five or share five. With the number of hardware cores is as low as 2 pieces, compared with existing similar products, the performance index is higher, and the product maturity has obvious competitive advantage. This is a hardware product line in quantum communication. QuDoor has completed the development of 15 products in 4 categories of quantum communication, fully tempered and verified our production ability, and now has entered the market introducing technology. In quantum computing, distributed quantum computers based on ions trap have been promoted in 2020. In 2021, we released distributed trapped ion quantum computer prototype, which named AbaQ1. It's expected that by 2023, we will form a 100-qubit entanglement network, demonstrate QAOA, VQE, and other algorithmic applications, developing applications in cooperation with pharmacy and financial enterprises, and demonstrate commercial quantum computers with quantum volume 100 million level. And this is AbaQ1 quantum system. It involves ion trap chip, cryogenic vacuum chamber, module laser cooling, and trapping optic system, bit manipulation optic ion photon entanglement system, electronic measurement and control hardware system, and full stack software system. And this is our technique framework in quantum computing. QuDoor is based on the development of quantum computing software and hardware full stack, from ion trap chip system hardware, qubit measurement and control equipment, to quantum software compare system of quantum algorithm. The image on the right shows QuDoor's basic hardware design and software ideas. In future, quantum clouds based on quantum computers and quantum applications will emerge in order to release the power of computing of quantum computers. This tab shows the layout of QuDoor's quantum computing software program system. We carry out research and development in quantum hardware, assembly language, quantum security, quantum algorithm, full stack ability, full stack library, and other aspects of SPAN and realization of future quantum intelligence. This table shows the layout of QuDoor's quantum computing software program system. We carry out research and development in quantum hardware, assembly language, quantum security, quantum algorithm, and other aspects to support the realization of the future quantum intelligence. For quantum system and ecological architecture, QuDoor will develop AbaQ series of quantum chips, intermediate Q roots, toolkit plus IDE, and development of various application fields. In the third part, I give a brief introduction to quantum intelligence in China. Quantum intelligence in 1.0 is already here. The first stage is a network that's sole purpose is to distribute quantum key to users in order to secure their data. The first truly practical and continuous used quantum protocol network was once again built and operated by the Chinese. In 2017, a 2,000 kilometer fiber trunk line carrying BB84K had been installed all the way from Shanghai to Beijing along the route of a high-speed train line. The trunk line collects BB84-based Q lines in Shanghai, Hebei, Jinan, and Beijing. If 2.0 appear, well, some of the critical elements have already been tested. As quantum networks mature, eventually quantum memories and quantum repeaters will come online, and the purpose of networks will evolve from distributing quantum key to distribute quantum entanglements. Once you have entanglements, you can secure it with the E91K and do other things besides. Quantum Internet 3.0. The network no longer has the starstruck. The network consists of user nodes connected by the fab links. The blow-up shows that at the center of each connecting link, midway between any two nodes, there's an entanglement distribution center that fires entangled photon pairs out to two user nodes. The Beijing-Shanghai Backbone Network (BSBN), the world's first long-distance quantum secured communication route, was put into service on August 30. It links two cities with a highly reliable and expandable secure communication expressway. The route in Beijing will also cooperate with Museus, an experimental quantum satellite launched earlier last year, to lay the foundation for integrated space-Earth quantum communication network, as well as global quantum communication network. BSBN was developed under the leadership of University of Science and Technology of China. Several organizations have also cooperated in the construction of BSBN, including China Cable TV Network (COATD) and the Shandong Institute of Information and Communication Technology, the USTC Advanced Technology Institute, and the China Bank Regulatory Commission, among others. Quantum Secured Cloud is based on cloud-native sequence architecture, which guarantees the full hosting of quantum structures, collectors classical communications with quantum confidential communications, and provides users with enhanced quantum security services. After completion of quantum security cloud platform, it can promote solution of the difficulties of interface of internal resources sharing in the industry. The difficulty of operating quantum security cloud is based on cloud-native service architecture, which guarantees the full hosting of quantum structures, collects class communications with quantum confidential communications, and provides users with enhanced quantum security services. After completion of the quantum security cloud platform, it can promote solutions of the difficulties of internal resource sharing in this industry, the difficulty of opening information, and difficulty of business collaboration, and realized co-construction and sharing of business infrastructure. The aggregation and opening of data resources and sharing the collaboration of business applications, forming a cross-level and cross-regional structure, cross-department, cross-system, digital and information service capabilities to solve end-to-end link security issues. QKD will provide service for database security applications, disaster recovery system, power dispatch, and mobile VPN, etc. Which directions of quantum key distribution network are increased transmission distance, realize large-scale networking, resolving security vulnerabilities, increased key rates, 2.5 megabits per second, high-speed system, and combine anti-quantum encryption accuracy. A relatively complete industry chain is initially formed in China with technology international leading. 5 core areas: technology application, system platform, transmission and networking, core equipment and devices. So this is version on quantum internet. We have cloud data center looked on a quantum compute platform, quantum sense network, hybrid safety internet, and quantum secure communication and its such plug entangled with quantum internet. Alice and Bob instructed central switching agents to send them each half a bit in the form of entangled photons pairs. One photon in one pair is emitted to Alice and only kept by the switching location. Another photon in a second pair is sent to Bob, and its entangled partner is also heard at the switch. After entanglement is distributed via photons, Alice transduces her photons into spin cube in her quantum memory. Bob does the same thing with his qubit in his memory, MB. The center switch stage has two memories of its own, M1 for the other half of Alice's bit and M2 for the other half of Bob's. As shown, at the stage, there are two bits stored in four memories, the Alice switchboard bit and the Bob switchboard bit. The next step is for the switchboard to carry out entanglement swapping, and the two qubits it has in M1 and M2. After switching board completes the entanglement swapping operation, its two qubits are destroyed, leaving only a single bit shared between Alice and Bob. Alice and Bob can then use the bit for cryptography, distributed in quantum computing or teleportation without any further dealings with switchboards. The network no longer has star structure in the figure, but rather the nodes are placed at random, as they are in today's class internet. The scale of this network is about the size of few city blocks, with nodes spaced about 100 meters apart. We don't need the quantum repeater of such a short distance. The entire quantum network itself is a distributed quantum repeater. Four major technologies will enable the future quantum network cloud. It's quantum computer, quantum switch, quantum computer, and quantum network. And they have four major applications, namely secured communication, distributed quantum computing, quantum sensor array, and multi-sensor application. The realization of relay network requires multiple entanglement intermediate nodes in order to produce entanglement between two remote terminal nodes. Each pair of adjacent relay nodes exchange quantum information and can receive, store, and send quantum state information as needed. Discrete variables dV and continuous variables Cv describe the states that quantum states can be represented. In the dV state, the data is represented by discrete features such as single photon polarization. Information is represented by a limited number of ground states, such as qubits, which are the standard unit of dV quantum standards. In the Cv state, information is encoded into the light field defined by the algorithm variables that constitute an infinite dimensional hybrid space, such as continuous variable Carrier laser. The Cv stations can be detected by a high-efficiency homodyne or heterodyne detector. It's necessary to conduct extensive research on the interface between the Cv state and the dV state in a theoretical and experimental fields, extract the best features of the truth from them, and give play to the advantage of both. Quantum network will require advanced quantum codes, which are based on qubits and can be mitigate effects of the noise, decoherence, and other environment factors. The original quantum state is granted before and after encoding and decoding. The quantum long-cloning theorem makes it impossible to simply copy the redundant codes of the classical networks as entangled encodes. Decoherence phase subspace stores data in multiple qubits in the network. The dataset is stored in a subspace of the heaped space related to the quantum system and ensure that the interaction between the subspace and network environment is minimal. It was difficult to design DFS for complex quantum systems, which requires more advanced DFS technologies, such as dynamic decoupling and network. Many powerful computers use different coordinate systems such as electrons, photons, phonons, and ions for calculations. The combination of Leron plus qubits builds quantum computing using neural networking algorithms to gain advantages over traditional computing. The ability of qubit plus bit far exceeds the ability of classical computing. Exploring the fusion method of classical bits plus multiple qubits plus layers and extensive research on it will shape the future of computing. The practical construction of scalable quantum compute hardware capable of executing long-travel quantum algorithms will require the juxtaposition of different types of quantum systems. A modular ion-trap quantum computer architecture with a hierarchy of interactions that can scale to very large numbers of qubits. Local entangling quantum gates between qubit memories within a single register are accomplished using lateral interactions between the qubits, and entangling between separate registers is accomplished via a probabilistic photonic interface between qubits in different registers, even over large distances. So this is the third generation quantum internet. We show quantum internet technology test platform looked in the Great Bay Area to development of distributed quantum computing research. This is first generation. In the first generation, we use classical K-distribution network based on quantum superposition states. In second generation, the quantum information distribution are relay and relay network based on quantum entanglement state. And the third generation, fully tuned quantum state transmission internet based on quantum computing resources. What's shown on this slide is the roadmap. What's shown on this slide is the roadmap realizing quantum internet in QuDoor. In phase 1, we are going to realize quantum secure communication network. Our target customer would be data center communication protection, government financial network. In phase 2, we'll focus on quantum secure network, and we will provide service for national defense, medical and health network and strategy. The long-term goal is to build quantum internet, including quantum satellite communication, quantum space network, and quantum cloud computing. The mission of QuDoor is to promote construction of quantum communication trunk lines in the Great Bay Area, promote construction of quantum technology innovation zone, attract talents and take cutting-edge technologies, promote an establishment of major scientific scientific research projects of quantum computing to realize scientific and technology applications in the fields of finance, medicine, and energy. That's all for my presentation. Thank you, everyone.